All right, so to continue on the notes here for section 3 of chapter 13, we're just now looking at solving some equations with use of some of the new identities and formulas that we have for this section. So again, notice right off the bat here, I need all the x's from 0 to 360. I am in degrees, so make sure you are in degrees when you go ahead and do this problem. And remember, you got the equal sign, so this is from 0 to 360 inclusive. So that includes 0, that includes 360, and everything in between. So solving this right off the bat, you have to notice you have a double angle scenario right here. In the continuation on the first video for chapter 13, we solved something like this, and we didn't have to use a double angle formula because there was only one trig function. And so we basically solved the equation and dealt with the 2x at the end. This one's a little different because you have another trig function, and that's why we have to use a little substitution for this. So replacing the sine of 2x with its formula, 2 sine cosine, gives me this look right here. Subtract the sine of x over to the left, and I get this equation right here. Notice that both terms have a sine in them, and so we're going to factor out the sine of x to get this look that you see right here. So we just took out sine x as a common factor. Because it's factored, I can now set each factor equal to 0 to get my solutions. So let's just start with this one for a minute. If the sine of x equals 0, so I'm getting this statement right here for the first part of my answer. So I'm saying the sine of what angle is 0. When you do an inverse sine function, that is the same thing as saying arc sine. Same thing as an inverse, just a different way of writing it. But we're still saying, okay, the sine of what angle is 0, which basically means I went up and down 0. So where would that occur? So if you look at this drawing right here, I'm going up 0. So that would happen at 0 degrees. That would also happen at 180. That would also happen at 360. So those are my three answers that I'm getting for the first part of this. And again, those are all have y coordinates of 0 because it's a sine function. The other one, 8 cosine x minus 1, if I set that equal to 0, I get this look right here. The rest of this problem was done wrong because the person that did this used sine instead of cosine. So from here, you need to follow what I'm saying and not what you're seeing. So if I did the inverse cosine of negative 1/8, so do this one in your calculator with me, but if you do the inverse cosine of negative 1/8, and remember I'm in degrees still for this problem, you're going to get 97.2 degrees. Something that has to stand out to you right off the bat, where are your cosine values negative? Right? Right here they're negative, and right here they're negative. So my two answers for this need to come from quadrant 2 and quadrant 3. So when you do the inverse cosine of negative 1/8, you get 97.2 degrees. So if you're here, you're traveling, that's 90. So 97.2 is going to be right about here. So that's our first answer, is 97.2 degrees. And remember, this is my other answer would have to be in quadrant 3 because that's where my cosines are negative. So if I went left, this is a negative cosine, so I went left to get that answer. So again, I have to go left again to get my other answer. That's another way of looking at it. So I know my next answer is right here in quadrant 3. The reference angle doesn't change, so take a look with me on this. Remember, this from here to here was 97.2. So if I did 180 minus 97.2, that gives me a reference angle right here of 82.8. So if this reference angle is 82.8, then this reference angle is also 82.8. So if I did 180 plus 82.8, I would get my second answer. And that's where that would come from. Next one here for number 2. Again, you're seeing the double angle scenario that you see. There's another trig function thrown in. So I want to try to get everything in terms of one function for this. So if I replace the cosine of 2x with its double angle formula that you see right here, then I get this look. Now everything is in terms of sine. You got to notice that one of them is squared and the other is not. So we create this quadratic scenario that you're seeing right here. And so we need to solve this. So we got everything onto one side, made it equal 0. We'd solve it just like you would solve any quadratic function. Think of this as 2x squared plus 5x minus 1. And if you were to factor that, these would be your factors. You set each one of those equal to 0 and solve. Again, the domain given for this was 0 to 360 inclusive. So you got to make sure you give every answer that would apply. So if we said, okay, let's just take the first factor, 2 sine x minus 1 equals 0. If I get sine x by itself, I get this look here. So we're going to say, okay, what's the inverse sine of 1/2? Or you could say the sine of what angle has a value, a y value of 1/2. And so for that, you get 30 degrees. So that's a 30-degree angle right there. So we'd say, okay, let's check and see where else I would get the same answer of the sine of some angle giving me 1/2. Remember, this is a sine function that you're solving right now. And so for this one, we're going to say, if my first one is 30 degrees, let me see if I can pull up this drawing here at the same time and talk. So if my first one is 30 degrees, remember y values go up and down. The other way to look at that is, this is positive 1/2. So I'm looking for values where the signs are positive. And where does that happen? In quadrant 1 and quadrant 2. So quadrant 2 must be my next value for sine. So if this had a reference angle of 30, then this also has a reference angle of 30. And so if I did 180 minus 30, I get my second answer for that. The other equation, if I set this equal to 0, we're going to say the sine of what value is -1. So where would you have y coordinates of -1? Well, that means I'm going down 1. So right here at 270 would be my only answer for that. And so those are the 3 solutions for that problem. Going on to right here, this is the last problem. Notice the switch. We are now in radians, and so you always have to look for that. This also says 2 decimal places, not 3 sig figs, so you got to check for that too. So that's really important that you always read all the directions on how to write your answer. So switch back over to radians for this problem. But again, you're noticing a couple double angle formulas here. So we got to do a little substitution. So I'm replacing the cosine of 2x with its double angle formula. We are replacing the sine of 2x with its double angle formula, and we're getting this new look that you're seeing right here for this problem. One thing to keep in mind for the cosine of 2x, you have more than one double angle formula for that. So look in your formula packet. This is one look right here. But we also have 2 other looks that you could use. I could also use this one that you see right here. I could also use this one that you see right here. There's 3 different ways to write in a double angle formula for cosine, and so you gotta sometimes toy with different ones in order to figure out which one you need to use for any given problem. But anyway, we're using this one in particular because we're going to be able to do a little factoring here to solve. And sometimes you would just have to toy with the different options to see which one helps you. So for this one, after we went through with this scenario, we multiplied the 3 times 2. We get everything onto one side to make it equal 0. And so that's what you're seeing now over here on the left. And the whole purpose of doing that was because now both of these have a cosine function in them. So I can factor out the cosine of x. Well, 2 can go into both of those as well. So we're going to factor out 2 cosine x. And here's what would be left over if we divide out 2 cosine x from each term. And now I can set each factor equal to 0 to get my solutions. Here's a pretty common IB test question right here. So pay close attention and make sure you get all the solutions for this problem. So for this one, let's just start with 2 cosine x equals 0. Obviously, if you divide the 2 over, it's just cosine of x equals 0. So remember, cosine are your x values. So where are your x coordinates at 0? And so if you're looking at your unit circle, your x's are 0 at, I wish I had one in front of me to show you, but your x's are 0 at if you go straight up to pi over 2 and then down to 3 pi over 2, those are the two places where your x coordinates are 0, and so that's where you're getting these first two answers right here. So at pi over 2 and 3 pi over 2, right, at pi over 2 you get the coordinates of 0, 1. Right here you have the coordinates 0, negative 1, so those both have x coordinates that are zeros, which is why we're choosing those. If I take my other factor, cosine x minus 3x equals 0, one thing we have to do to solve that is add 3x over to the right, divide both sides by cosine, so that I can now work with a tangent function. And so now we're going to do the inverse tangent of 1/3. Again, notice this is positive, so you have to look at which quadrants give me a positive tangent function. We know from the All Students Take Calculus acronym that my tangent functions are positive in quadrants 1 and quadrant 3. And so those are the two quadrants we're going to look to get my answer. So if we did the inverse tangent of 1/3, and again, my calculator would be in radians for this. So if you want to take a second and punch this in with me. All right, so if you did the inverse tangent of 1/3, and remember your calculator is in radians for this problem because of what I see right here. So inverse tangent of 1/3 in radians is 0.32. This one said 2 decimal places, so you should not have this guy right here. It should just be 0.32, but that would be my first one. And remember, now if you're going to quadrant 3, because this is a positive tangent, so I know the other one would occur in quadrant 3. So to get something in quadrant 3, remember if you went straight left on your unit circle, you're at pi. So I need to do pi plus my reference angle in order to get the value that you see here for quadrant 3. But that takes care of all our solutions. Remember for these, you can have the option of leaving things in forms of exact or whatever the directions say. Now in this particular problem, if I were doing this on a test, I would mark this wrong. So would IB, because the directions here said 2 decimal places. So if the directions say something specific like this, you have to do that. And so if I left my answer as pi over 2, even though that's the right answer and it's exact, these directions said specifically 2 decimal places. So that's what I should be doing. So I should have done pi divided by 2 and have that for 2 decimal places. I should put this into my calculator and round it to 2 decimal places. That should just be 0.32. And this should also be rounded to 2 decimal places, but this one is. So you got to make sure you follow those little things. Those do cost points on the test. So pay attention to those directions and make sure you do exactly what they say to do here.